solve this today's LeetCode problem. This is an easy one. Let's see what it is. So here we have given a spatial array with x elements greater than or equal x, right? So we have given an array nums of non-negative integers. It means a positive integers including 0, right? Nums is considered special if there exists a number x such that there are exactly x numbers in nums that greater than or equal to x. Nums is considered special if there exists a number x such that there are exactly x numbers in nums that are greater than or equal to x. Okay. X does not have to element in nums. Return x if the array is special, otherwise return -1. Okay. Okay. So here we have given non-negative integers, right? Non-negative integers means that positive integers including 0, right? Positive integer including 0, right? This is the non-negative integers. And what's the given, we need to find that the number x, we have to find the number x, we have to find the number x in nums such that this array is special. And what, when will this array is special? If this x number, if this x number occurs in nums exactly x num times, which is greater than equal to x. What does it mean? It means this x number such that there are exactly x numbers in nums such that they are greater than or equal to x. It means what? Suppose we have given 1, 3, 4, 6, 5, right? So if you see here in this case, this one is present in this, and how many times, how many numbers are which is greater than equal to x, which is 4, total number 4. So this 1 and this 4 is not equal, right? If you see 3, this 3 is 3, but how many numbers are greater than equal to x, which is only 3, right? So you, if you see this x, this 3 is equals to this 3, because the total number of elements which are greater than or equal to this 3 elements is 3, which is equal. So this number makes this array elements, this array as a special. So we will return this as an answer, right? Because this 3 exists, this 3 element, this 3 number is exactly 3 times greater than there are exactly 3 numbers which is greater than equal to this element, right? So that's why this is an answer. If you see about 4, so here the numbers which are greater than or equal to this 4 is only 2, right? So this cannot be an answer because this 4 is not equals to this 2, right? Same goes for 5. Same goes for 5, right? So this 3 is an answer. That's the mean of the array special. And if we are not able to find any number which satisfies this condition, so we will return -1, right? Okay. So if you see here, one thing is clear, that I need to figure out the I need to figure out the greater than. I need to figure out for each element, for each element, that how many elements, how many numbers is greater than or equal, is greater than or equals to this x number, right? This x number, how many numbers is greater than equals to x? For each element x, I need to find out. And this x is not compulsory to be in present in this nums. So it, what does it mean? If you see 1, 3, 4, 5, so we can the answer can be 2 also, because I need to take check 2 for 2 also, right? Like this 2 is, how many numbers are greater than this 2? 3 numbers, which cannot be on answer and our answer, right? So this 2 can be also be checked, that if the condition satisfies, if suppose there is only 3 elements, 1, 3, 4. So this 2, how many numbers are greater than this 2 or equals to 2? So it is 2. So this should be the answer. This should be the answer if we take only 1, 3, 4, right? So that's the reason, it is told, it is to know that x does not have to be an element in nums, right? So we will just check for all the numbers from 1 to the elements. So the one thing, after reading this, one observation is to find, right, that I need to figure out for each element x that how many numbers is greater than equals to x, right? So for checking that, don't you think I need to figure out anyhow that how many elements are greater than for these elements. So if you think of any other approach, we will think that suppose this is given 4, 3, 6, 1, 7, right? There are total there are total five elements, right? There are total five elements. So if I want to search for 4, that how many elements are greater than equals to 4, how many elements would be? This is 3, right? It is 3. But how will we guess? We iterate in this and simply check which numbers are greater than equals to and count that, right? But it will take for each element to be checked. That will take O of n into m. Why O of n into m? What is n? N is the length of this array, and m is the count of the elements from 0 to this total maximum number of this array, that is 7, right? So that will take n into m, but that is a huge time of complexity. Although if we see the constants here, if you see the num size can be present at 1000 and nums length can be a max of 100, so that can be satisfied. But 10 to the power 5, but if the constants are very high, this would be failed, right? This would be failed. So this is not an optimal approach. This is a brute force approach, of course, so everyone can do that. But how we can optimize this further? So we have a we have a we have a successful method, built-in method. What is that? Is a sort. We, if I short this, if I short this 1, 2, 4, 6, 7, if I successfully sort this, don't you think I can easily know that how many elements are greater than this 4 by just knowing by just applying binary search on this? Don't you think? Suppose this is a 4, and if I know that how at which position this 4 is occurring, or at which position this 4 can be occurred. So if you see, we can the 4 is present at third one 2th index. If I start from 0th index, it is at present as 2th index. So if I know that it is present at 2th index, then how many elements would be greater than this 4 or equals to 4? That would be 5 minus 2, that is 3. That would be 5 minus 2, it is 3. 5 minus 2, it is equals to 3, right? But suppose I want to search for 3, that how many elements are or equals to greater than this 3. Then I will again apply a binary search, that how many elements are greater than this 3. So this 3 is not present here, but if 3 would be present here, then at which position this 3 would be present here? At two positions, at second part, right? Because after 2 that would be present, so that will be second. So again, what would be the answer? 5 minus 2, that is again 3. So if you see, for this for this 2 for this 2th number, for this sorry, for this 3th number, number of elements which are greater than this 3 or equals to 3 is again 3, right? So 3 and 3 is equal. It means it can be possible answer. It can be a it will be an answer, not a possible answer. It will be an answer, right? One answer is only there will be only one answer possible. That is for sure. That is for sure here, right? That would be only one answer exists. So whenever I get an answer, I will just return that. That is for sure, right? Okay. So what we are doing, if I just apply a lower bound here, what does lower bound do? If the element exists in my array, it gives me that index. Otherwise, it gives me one greater than that index. So if 4 is present, it will give me 2th index. It will give me 2th index. But if the element is not present, like 3, so it will again give me 2th index only, because if 3 doesn't exist, it gives one more than that index, right? So lower bound will be the perfect solution for here, right? So what we will do, we will sort this array first. So what will the approach here? We will sort the array first, then we will apply lower bound lower bound from for each element. And what are the elements would be? The elements would be from 0 to the max number which will be in this nums, the max numbers which will need because I need to check each and every number either it is exist in numbers or not. So I will take the max of nums array, max of each the max element present in max element present in uh, from 0 to max element present in nums, right? So from here then we will apply lower bound here. So for if now what we will check, we will check that if the current index which will I got after this lower bound, after subtracting from the maximum number this n number, if it is greater than, if it is equals to the current number which is the element number, then it means I the array is special due to this number. It means I got we get the answer, we got the answer, we got our answer, right? And we will simply return this, right? And if we don't get any number, so we will simply return -1 from here. Don't get any number, right? So this is how we will do this problem. So let's try to implement this, right? So first thing is I need to sort it, right? I need to sort it. So I will just sort. So that will give me sorting. Now I need to check for each and every element from 0 to the max element which is at this num. So max element would be at last element. So I will just write this like this: num sign -1 and I plus plus. Now I will check for each and every element from 0 to max element of this array in my nums array. So how will apply in lower one? Like this: nums dot begin, nums dot end. So what does lower bound gives? It is a binary search, of course, right? It's just an STL in C++, which gives us the answer, which makes us our life easy, right? So this is I nums dot begin, and yeah. Now this index. Now I need to find the greater than or equals to element now, and this index will give me the present element. So how many elements are greater than or equals to this? So that will be n minus index, n minus index. And if it is equals to this I number, the current element, it means we got our answer. We got our answer. So we will just assign this I to answer and break it from here because we don't need to iterate much further and we just return answer. So if we don't find any answer, it will just return answer -1. That's why I initialize it with -1, right? So let's run this. Mm, okay. So what this nums dot begin, why this? Because it will give me an index, right? Otherwise if I don't write this, it will give me an iterator, right? So let's run this. We have passed a sample case. Let's submit it. Yeah, we successfully passed that, submitted. Okay. The one thing, if you have observed till now, which I have observed, we don't need to iterate till nums and -1. Why? Because if you see question that the num x should be exactly equals to the x numbers in nums that are greater than equal to x. So if you think here, suppose this 1 4 6 7 2, right? This is the element. So after sorting, what it would it become? It become 4 6 7, right? How many elements are there? 3 to 5 elements, right? So if you see, if I try to, if I was iterating from 0 to max number of n-1, what does it mean? I was iterating from 0 to 7 in this case, right? But if you see, we have only 5 elements left. So if we try to check for sixth element or seventh element, do you think that I will got anything in my answer? Because there are only present 5 elements in my answer. So I, so 6 will present only one times, 7 will present only one times. And there are no other elements which is greater than this. So 6 will present only two times and 7 will present only one times. So it can never be equals to 6 or 7, because total number of elements is only 5. Then how will then how can how can the number will be greater than exist greater than equals to this current number, which is not which is greater than this num size, right? And the nums total size of array is 5. Then how can the number greater than this nums dot size have a number exist greater than or equals to this size? It never be possible, right? So we simply don't need to check for the for the numbers for the numbers which are greater than the size length of the array or size of the array. We can simply ignore all the numbers which are greater than the size of the array, because it can never be possible that these numbers would be equals to 6, which are total greater than equals to these numbers, right? So we can simply simplify this to n only, the size of this array. And this would also work here if you think, right? So what we have done, we have just decreased our time complexity for the max elements, which can be 1000 to 100 only, right? So this is some optimization we can done. So let's try to run this. It will also accept. Yeah, see, it also get accepted. Yeah, it also gets accepted. So it's just a key observation here. It's just a key observation that the numbers which are greater than the size of the array should need not to be checked. Need not to be checked, because there won't be any numbers exist greater than equals to that numbers, and which can be equals to the count of which can equals to the value of that number, right? Okay. So what the time and the space complexity now? So the time complexity would be O of log n for n log n for sorting, of course, and log n for sorting, and plus O of n for iteration. That would be overall O of n log n, right? And the space complexity would be, so we haven't taken any extra spaces here. So in C++, that would be O of 1 for sorting, but in other languages it can take some space, right? So it depends on many languages, but in C++ it would be O of 1, or uh, or you can take off as a log of n also, but I would prefer O of 1 here, right? Because it mainly uses a merge sort, right? So it's O of 1, right? So now this n log n is good, but can we more further optimize it from n log n to O of n, from O of n? Okay. uh, if you we think here that we have total elements as 1000, right? We have total elements as 1000 and nums dot length is 100 only. It means one observation is for sure, that we need to check only for 100 elements, 0 to 100 elements, because nums dot length is can never be greater than 100. So we need to check for 100 elements only at most. We need to check 100 elements only, 100 numbers on 0 to 100 numbers only at most, right? That is for sure. So, and we just need to find the numbers for each an element from 0 to 100, that how many numbers are greater than or equals to the x number, right? If we choose any number from here. So if we think here, to store all the counts, which exist in my answer, what does it mean? If we take this example again, 1 2 4 6 7, so what would be the maximum number? That would be 5, because there exist only 5 numbers here, right? So if I store the counts of each and every number in my array from 1 to 5, so what would it be? So for 1, how many counts are there? 1. For 2, it is again 1. For 3, it is again 1. For 4, it is again 1. But for 5, it is again 1. Now for 6 and 7, what are the counts? So we need to only check for for 1 to 5 elements only, but here 6 and 7 would be is greater than this 5, right? So how many elements should it occurs? So one thing is clear, that these numbers exist in my nums array. It means this will contribute to my answer. If I try to find any number, suppose I want to uh, find the numbers which are greater than total number of counts which are greater than this number 2. So how many elements would be there? That would be 3. It means I need to anyhow count this 6 or 7 anyhow, right? So how will we do that? We can simply see that this 6 7 should be counted separately, where this can count in this can be counted in odd odd in counter variable, right? So how many would be there? That would be 2. Total count would be 2, right? That would be 2. So whenever whenever I want to search, so whenever I want to iterate from 0 0 to 5 elements. So if we want to find any element, the count of elements which is greater than equals to x, so what we need to do, we will just calculate the frequencies of greater than that number. So how does it really benefit? So suppose instead of iterating from 0 to 5, if I iterate from last, if I iterate from 5 to 0, so how will it help? So let's take a variable temp, right? And slice it with 0. So if I start from 5 to 0, how many elements of 5 occurs in my frequency? This is the frequency count. This is the frequency count. So how many elements would be there of 5? That is 1. And how many elements which are greater than this 5? That is this count. So I will initialize this temp as a cnt, right? That 2 will be the always occurs from each for each and every elements here. So how many counts it for 5? That is 1. So that will be 1 plus cnt, that is equals to 3, which is not equals to 5. So that will not be an answer. This is not will an answer. Okay. So I have my count as 1 plus cnt, that is 3. So when I try to calculate for 4, when I try to calculate for 4, again I need to calculate the frequency for this. So that is again 1. So it means that would be 3 plus 1, which is equals to 4. Which is equals to 4. 2 plus 1 is 3. Okay, so 5 count is here is not 1, it is 0. So here this should not be added to my count variable, that would be 2. Here 5 is not occurring in my array, so that would be 0. So if you see here, we if the count is 2 only, if the count is 2 only, and 4 frequency is 1, so 2 plus 1 is 3. So but 3 is not equals to 4, then that is also not an answer. But this temp, what it does, it become 3. So why we are iterating from last? We just need to calculate the greater elements beforehand, that how many elements are present till that number from my last position. That's where we are iterating from last position, right? So if you see for 3, if we see for 3, this 3 exists in my answer? No, it doesn't exist. So its frequency would be 0, right? Its frequency would be 0. So if we check for 3, the temp is 3 and the frequency is 0. So it becomes 3. So 3 is equals to 3. It means we got our answer. That would be our answer. That would be our answer. So if we further check, we don't need to further check because we have already got our answer, right? We don't need to further check. If you want to check, you can check, like this 3 would include in temp, and if you want to check for 2, this 2 occurs one time. This 3 is temp is 3, so this will be 4, which is not equals to 2. Again for 1, same thing. So this is how we will do. So what we are doing, just we are doing, we are just we are just counting the frequency of each element present in my array, and we start from we start iterating from my last element, from last size, last array of size of array, sorry, size of array, from my last size of array to 0, and count of maintain a count of greater than numbers, greater than numbers, and check after adding the frequency of current number that that it is equals to my current number or not, right? And when we are counting the frequency of each element, if the number is greater than the size of array, it means we don't need to store that. We will just store in our another variable, right? So we will store from till only the size of the array. The reason is reason is the same of the previous reason. This was the reason, right? Let's try to implement this. You will be better understand. So I just don't need to short it, right? I just don't need to short it. I will remove shorting. Instead of this, I need a frequency array. So this is a count, right? Just need to count that, and that would be from 0 to n only. So that would be n plus 1, and initialize with 0. So I will iterate from 0 to n, from 0 to n, and so instead of this, I just count all the frequencies which occurs in my answer, and I will store that only, right? But before this, I will check that with this num size is greater than n, then I will don't store in my frequency array, I will store the count only. So for storing counts, I will just take a variable and store all the counts, right? Store all the counts which are greater than the size. Otherwise I will store the count in my frequency array, right? Now for iteration, I will start iterating from n to 0. I will start iterating from n to 0, and this time this is a number. I will start iterating from n to 0, and all numbers from 0 to n would be included. So I also need to maintain a temp to maintain a greater than equals to numbers, right? So what I will do, I will just add the frequency of current number from my answer, and this initialized to be cnt. Why? Because if the number is greater than this, it would be greater than for all the numbers from n to 0. So I slide with this cnt. Now if this temp is equals to I, it means we got the answer, and we'll just simply return from here. Otherwise, if we don't get, we return -1, right? Right. If we got an answer, I will just return an I, or otherwise I will return -I. So why this temp? This is just to calculate the total number of elements which are greater than the current element. That's why we are iterating from last to store all the frequencies, right? So now the time complexity would be okay. Just let's try to run this first. Let's see, we haven't. Okay, we have made some mistake. So this is not a frequency. This is a count. Let's run this. Yeah, let's submit it. Done. So what are the time and the space complexity for this? The time complexity would be O of n. Why? Because we haven't taken any extra. We haven't. We are only iterating, so that would be O of n, and the space complexity would be again O of n, because that is only we are taking frequency array, so that is again O of n only. So this is how we will solve the question. Hope you understand it. Thank you. Bye bye.